Hello, our video today is going to be on rectangles, rhombi, and squares. So we're moving past the parallelogram, but the parallelogram is still going to be really important, hence why you have those 5 properties still here. So our parallelogram is going to we're going to create a quad family tree. The parallelogram is where we're going to start. The parallelogram is going to feed all of its properties to the rectangle. It's also going to feed all of its properties to the rhombus. And then the rectangle and the rhombus are going to feed all of their properties to the square. So that's why these properties of the parallelogram are still really important, because all 5 of these properties are going to be transferred to the rectangle. So opposite sides are congruent, opposite sides parallel, opposite angles congruent, consecutive angles supplementary, and diagonals bisect each other. Those are going to come into play. So when we get down to the rectangle, remember what we just said, it has all of the properties of the parallelogram, and we're going to have 2 additional properties. The first new property is that all corners are going to be right angles. So when we think about what it means to be a right angle, that means that our angle is going to be 90 degrees. So when I look at my diagram, all corner angles are right angles. What that means, this is my angle, it's a right angle. The equation I would set up to solve would be to set that angle equal to 90 degrees. Notice that our notes said do not solve. We're concentrating on applying those properties. The second property of your rectangle is that the diagonals are congruent. In the parallelogram, we had that the diagonals bisected each other. So this one's a little bit different. If I look at my diagram, here's my diagonal AC. This means that diagonal AC is congruent to diagonal BD. So if I look at my given information, AC is 30, find BD. Well, if AC is 30 and AC and BD are congruent, that means that BD is going to be congruent. So BD is also going to be 30. So just remember that from your rectangle, it's going to have all 5 properties of the parallelogram plus 2 additional properties that are new to the rectangle, giving it 7 properties total. Now it's only 2 new properties, but when I combine the properties of the parallelogram and the rectangle together, we get really cool patterns that emerge, applications of multiple properties. So we're going to use the fact that my diagonals are congruent, so I know whatever AC is, BD is the same thing. That is a rectangle property. But if I look back to the parallelogram, another property that we get is that the diagonals bisect each other. So when we had a parallelogram, we had that those 2 were congruent, and then I had that these 2 were congruent, but they were different. That's going to change now. Because my diagonals are congruent and they bisect each other, all 4 of those pieces are congruent. So in order to get this special property, again, we need to combine the parallelogram property that diagonals bisect each other with the rectangle property that the diagonals are congruent. So here, when I give you that AE is 10, and I ask you to find BD, we're thinking about how these pieces relate. If AE is 10, then EC is 10. Oh, but that means that DE is also 10, and EB is also 10. The question is asking for BD, which is the length of that entire segment. So I need to do 10 plus 10 to get 20. So the length of my segment, my diagonal BD, is going to be 20. Now when we look even closer here, I see that not only do I have those 4 congruent pieces, if I look closer at the triangles themselves, I notice that I am creating isosceles triangles. They're isosceles triangles because the legs of the triangles are congruent. And if the legs of the triangles are congruent, then the base angles are congruent. The top and bottom triangles are congruent triangles, so those two are going to be the same. And if I look left and right, this is also an isosceles triangle. It's a different isosceles triangle. So I use a different tick mark for those base angles, but they are congruent to each other. So left and right are congruent and top and bottom are congruent. So let's see what we're given here. We're given that the measure of angle 1 is 70 degrees. So here's angle 1. This angle is 70. We want to find the measure of angle 2. So angle 4 we know is 70, but I don't want that because that's a vertical angle. Angle 3 is 110. I don't want that one either. I know it's 110 because it's a linear pair. I'm focusing on this angle 2 right here. So I'm looking at this side triangle. When I apply the property of the isosceles, those base angles are congruent. So I think about the triangle sum theorem. It says that all 3 angles in the triangle are congruent, that all of them add to 180. So I do 180 minus 70. That's going to leave me with 110. Remember, that 110 is what I have left between just these 2 angles. 180 is for the whole triangle. Because the base angles are congruent, I take that 110 and I divide it into 2 equal angles, which is going to make each of those base angles 55. So the key here is that because it's isosceles, the base angles are congruent, which means I get to split the remaining measurements into equal angles. Okay, so let's go ahead and turn over. Let's look at what we have with our rhombi. So rhombi is just plural of a rhombus. The rhombus has all the properties of the parallelogram. So remember, all 5 that are coming from the parallelogram, and then the rhombus gets 3 additional properties. The first one being that all 4 sides are congruent. So if we look here, the sides are on the outside. So this is side BE. Side BE is congruent to side EA, which is congruent to side AR and to BR. So in a parallelogram, only opposite sides were congruent, but in a rhombus, all 4 sides are congruent. So if we look at what we're given, we have that BR is x squared, BE is 9x minus 14. Find the perimeter of our rhombus bear. So all 4 sides are congruent. All I need is any 2 sides. I don't need opposite sides, any 2 sides. So we have x squared equals 9x minus 14. When I look at the equation I have set up, I have an x squared and I have an x. That's my hint that I'm going to factor. Remember, for factoring, we move everything to one side. I want to keep this a positive x squared, so I'm going to move that 9x over, so that becomes x squared minus 9x. I move the 14 over, where it becomes a positive 14. Opposite operations have us move it to the other side. So when I look to factor, I'm looking for 2 numbers that multiply the outside and add to the middle. We are multiplying to a positive 14 but adding to a negative 9. So that tells me that both of my numbers have to be negative, because negative times a negative is a positive, but negative plus a negative is a negative. Those 2 numbers are going to be 7 and 2. Negative 2 times negative 7, positive 14. Negative 2 plus a negative 7 is a negative 9. We set that equal to 0. We move our 2 over, and we get x is equal to x minus 7 equals 0. We move our 7 over. We get x is equal to 7. So we have 2 values of x. It wants us to find the perimeter. So if I look here, Why don't we plug it in here? So 2, oops, not 2, well 9. We have 9 times 2 minus 14. That's 18 minus 14. That's going to give me that this side of my rhombus is 4. The perimeter is 4 equal sides of 4, making my perimeter 16. So when x is 2, the perimeter is 16. Let's go ahead and see what happens when x is 7. So 9 times 7 minus 14. 63 minus 14 is going to give us 49. So the perimeter, we have 4 sides of 49, making that 196. So when x is 7, my perimeter is 196. That's the first new property for a rhombus. The second one is that the diagonals are perpendicular. So if I'm looking at my last diagram, here are my diagonals going through the middle. Perpendicular means that, oh, I guess we're using the next diagram. Oops, let's keep on going. BSE, so diagonals are perpendicular. Here are my diagonals. They are crossing. Perpendicular means that we are going to have right angles, and right angles tells me that I have 90 degrees. So the measure of angle BSE, remember the middle letter is your vertex, BSE. Oops, BSE. So we're looking at this angle right here is 15x minus 15. Set up an equation, solve for x. Do not solve. So 15x minus 15, if those lines are perpendicular, it's a right angle, which means it's set equal to 90. The third one is that diagonals bisect opposite angles. So we have, here's a diagonal. That diagonal is going to bisect that angle, giving me 2 congruent angles. If we think back to the parallelogram, opposite angles are also congruent. So all 4 of those pieces are congruent. Now if I go to my other diagonal, this diagonal is going to bisect this angle, angle BRA, so this big angle is congruent to BEA, which means that the opposite angles are congruent and bisected. Those 4 angles are the same. So that the measure of angle BRE, so BRE, if this angle right here is 3x plus 9, and ARB, all right, so now we're looking at this big angle, is 8x. Set up an equation to solve for x. Do not solve. So we know there's 2 ways to look at this. If this is 3x plus 9, these are congruent, so this is also 3x plus 9. So it takes 2 of the 3x plus 9s to equal 1 of the 8x. Or, remember, if this whole thing is 8x, if I cut that in half, that means that this angle is 4x and this angle is 4x. So I could have also done 3x plus 9 is equal to 4x. Both of those are going to get you to the same answer. So remember, you get 5 properties from the parallelogram. You get 3 new properties from the rhombus, which is going to give you 8 total properties that apply to the rhombus. Our last shape is now going to be the square. So the square, remember from the front page in our little quad family tree, has all properties of the parallelogram, rectangle, and rhombus. So 5 from the parallelogram, 2 from the rectangle, 3 from the rhombus, giving us 10 total properties that's going to apply. So not only can we straightforward apply all 10 properties, when we combine those, it's going to give us some special properties, special applications. So 1, I think about the rectangle. Rectangle tells me that all 4 corners are right angles. And then from the rhombus, I learn that the diagonals are going to bisect those angles. In the rhombus, we don't know what the angle was that we originally bisected for all rhombus, but in a square, we know that it's always going to be a corner right angle. So I know that when I bisect that corner right angle, these are always going to be 45-degree marks. So same thing for the other side, the other diagonal. We're going to bisect, bisect. So these are also going to be 45. So all of those corner angles are 90. And when the diagonals are drawn, all those corner angles are also going to be 45 degrees. An additional property from the rhombus is that the diagonals are perpendicular. So in the middle here where those diagonals meet, I know no matter what, all of these angles are going to be 90 degrees. So what's unique about the square is no matter what, I know all the angle measures. The angle measures in a square are never going to change. All right, that is all I have for you today.